In this tutorial, we will learn the SketchUpBIM tools. We will learn how to use these tools to create building models quickly and cut down the time to market. For demonstration, I will use a 4-story office building. The first step in creating a building model is to create grids. The first button on the SketchUpBIM toolbar creates grids. Multiple grid lines are separated by commas. Grid lines can also be defined using the @ sign. A combination of the @ sign and commas is also allowed. Once the grid lines are generated, the next step is to define the first level. Level is synonymous to floor. This button opens the level dialog. The level is characterized by its height above the ground level. Let's keep the default height of 10 feet. By the way, SketchUpBIM supports both metric and imperial units. All SketchUpBIM input fields accept numeric values in any unit system. So instead of 10 feet, I can also enter 3 meters or 120 inches. Values entered in inches, feet, meters, centimeters and millimeters are allowed on SketchUpBIM dialog boxes. Let me skip the advanced options for copying levels. We will cover these later in this tutorial. The SketchUpBIM toolbar provides all basic architectural and structural engineering primitives to quickly create buildings in SketchUp. It provides the ability to create walls, columns, beams, slabs, and openings at the click of a button. Let me start with creating columns. The column dialog provides the ability to specify the material, the column shape, and its dimensions. The column material can be either concrete or steel. I will keep concrete as my material of choice. For concrete, either rectangular or circular columns are available. I will keep rectangular as my shape preference. I will also keep the same dimensions for the rectangular columns. I can add columns by single-clicking on the viewport. Next, I'll add some circular columns on the outer periphery of the building. I will change the shape to circular and change the breadth or the diameter of these columns to 18 inches. I can either add columns by single-clicking or drop multiple columns using the drag and drop functionality. Columns are created at all grid points that fall under the drawn rectangle. Note that it is not necessary to stick to grid points for any SketchUpBIM element. An element can be created anywhere on the viewport. SketchUpBIM provides an easy way to delete the entire primitive with one click. Unlike SketchUp, where you will need to select each curve and face separately, SketchUpBIM elements can be selected with one click and consequently deleted. Here, I will select this column and press the delete key on my keyboard to remove it. The layers dialog is automatically loaded with SketchUpBIM. SketchUpBIM uses layers to represent its levels or floors. This means that every floor and all primitives defined on that particular level belong to its corresponding layer. In our case, the columns that we just added are added to the elevation 10 feet layer. To view the entire model in 3D, I will click on layer 0. Let's go back to the elevation 10 feet layer and complete the elements on the first floor. This building has an elevator shaft surrounded by walls. So let's add a few walls. The wall dialog lets me assign the material to the wall and change its thickness. I'll keep generic as the wall material and change its thickness to 12 inches. Once again, I can enter the thickness in millimeter or any other supported units. In front, I just need a 2 feet wall to keep space for the elevator doors. To use accurate measurements in SketchUpBIM, I can simply use my keyboard to enter the dimensions. In this case, I will click at one end, then type 2 feet from my keyboard and press enter. A 2 feet wall is created. I'll do the same on the other side. Now let's add some beams. I'll add concrete beams on this level. Let's reduce the beam depth to 18 inches. Beams can be drawn by single clicking on the start and end points. Multiple beams can also be drawn by using the drag and drop functionality. Beams are drawn at all grid points that fall under the drawn rectangle. Finally, let's add a floor slab to this level. I will change the thickness of the slab to 8 inches. Offset is the overhang around the drawn perimeter of the slab. I'll change this to 12 inches. A slab can have any number of sides. SketchUpBIM assumes a slab definition to be complete when the polygon closes. That is, the last point meets the first point. At this point, our definition of the first floor of the building is complete. Let's switch to the 3D view to review the model. It is important to note that although all structural elements were drawn in plan view, these elements were actually being created in 3 dimensions. I will switch to X-ray view for clarity. Notice the walls of the elevator, the rectangular columns at the center, and circular columns on the outside. Also notice the concrete beams between the columns and the floor slab. One last step. Let's go back to the first floor plan view and add openings for the elevators. This is the opening tool. Openings can be created on slabs or walls. 2 simple clicks create an opening. Let's create another one for the second elevator. Let's switch back to the complete model view in 3 dimensions. This is a 4-story office building, so I will go ahead and add a new level to the building. I will keep the default height of 20 feet. As the floor layout for the second floor is exactly same as the first floor, I will use the advanced options on this dialog to copy the elements from the floor below. I will copy walls, columns, beams, and slabs. The entire second floor of the building is created with a single click using the advanced options on the level dialog. Now, let's do the same for the third floor. Let's examine the building model. Notice that 3 floors have been created. All elements on these 3 floors are identical. Now, let's build the 4th level of the building. The 4th level is built with steel beams and columns and has a smaller built-up area. The only elements that we need to copy from the floor below are the concrete walls for the elevator shaft. I will hence uncheck columns, beams and slabs and press OK. I will press the columns icon to add steel columns. I will change the material to steel. Note that only white flanged steel sections are available in this version of the software. To complete the superstructure, I will add some steel beams. Once again, I will pick steel as my material and press OK. Now, I will add beams to this floor. Finally, let's add a slab to this floor. I will enter 0 as the offset value. As this is the top floor, there is no overhang on the floor slab. This completes the construction of the 4th floor. Let's switch back to the complete model view and review the entire building model. Notice the steel girders on the top floor, the concrete column and walls, and the openings for the elevators. Material rendering can be switched off by clicking on Display Options and unchecking the Render Materials checkbox. SketchUpBIM files can be saved and restored like any other SketchUp file. When I reopen the saved file, all architectural and structural engineering information of the SketchUpBIM elements is retained in the SketchUp model. This completes the basic tutorial for SketchUpBIM.